Welcome to 2.2, page 6, last page of 2.2, and we are still talking about zeros to a great extent and the graphs of these. And I think 86 through 92 just become really fun problems where we can come up with a graph really quickly that's fairly accurate without our graphing calculator. So let's take a look. Find a polynomial function with the given zeros. I've got a 0 of 5 and a 0 of 0 with their given multiplicities and the given degree. I need fifth degree. Multiplicity 3, that means that 5 is 3 zeros. That means that we have a factor x minus 5 cubed. And degree 0, or 0, excuse me, is a 0. Multiplicity 2, that means we have x minus 0 squared. So that would be f of x is x squared times x minus 5 cubed. 0 is a double 0. 5 is a triple 0. And if we superfoiled this out, we would get x squared in here, we would get an x third, we'd get x to the fifth, dot, 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 we're degree 5. Why are there many correct answers? Because if I put any number, say 7, any number other than 0 out in front, then we still have the same zeros. The graph's just taller or shorter, or if it's negative, it's upside down. But this would be the most likely answer right here. Okay, 1 is a 0, multiplicity 2. That would mean x, 1 is a 0, minus 1, multiplicity 2, we got a pair of those. 4 is a 0, multiplicity 2, x minus 4. This graph is supposed to fall to the left, fall to the right. And if I were to superfoil this out, I'd get x squared, I'd get positive x to the fourth, and that wants to rise to the right, rise to the left. But it's supposed to fall and fall, so if we just make it upside down, a post function multiplier of -1, the graph's upside down. There we have it. Okay, now, a lot of this builds up to here. Sketch the graph of the function applying the lead coefficient test. Well, this graph wants to rise to the right, rise to the left, so I would do that as I'm sketching this. Finding the zeros. Well, let's see. X to the fourth minus 4x squared equals 0. That's x squared times x squared minus 4. So either x squared equals 0 or x squared equals 4. X equals 0. Now that's a multiplicity 2, 0. It's a double. Or, how do we get rid of a squared? Plus or minus square root, plus or minus 2. Those are single zeros. Because this could factor into x plus 2, x minus 2. So here's what our graph's going to look like. We're going to have a 0 at 2. We're going to have a 0 at -2, but we're going to have a double 0 at 0. These zeros, we pass through the graph. This 0 is going to just touch, look like a parabola, in this case upside down, and then this 0 passes through. So our graph looks like this. Now, the question might be, how low do these go? How steep is the graph? We'd need some further investigation, but I can get a good look at what this graph, I can get a good sketch of what this graph looks like very, very quickly. Okay, so let's go 3x squared times x minus 8 equals 0. So x equals 0, multiplicity 2, it's a double, or x equals 8. So our graph is going to have a 0 at 0, it's a double, It's going to have another 0 over here at 8. It's a single, and ultimately we're positive to the third. Ultimately the graph wants to rise to the right, fall to the left. This double is just a touch point. It says it's come on in. No, you don't. Okay, it's a second degree 0. This 8 is a single degree 0. We just passed through it. So very quickly we can come up with a good representation of the curve. 90. How about this? How about negative x to the 6th plus 7x cubed plus 8 equals 0. I'm going to multiply both sides by negative 1. X to the 6th minus 7x cubed minus 8 equals 0. This is quadratic on x cubed. We have x cubed squared, x cubed to the first, and no x cubes. So maybe this factors into x cubed. X cubed times x cubed is x to the 6th. Factors of negative 8 that add up to negative 7 minus 8 plus 1. So either x cubed equals 8 or x cubed equals negative 1. That is x equals 2 or x equals negative 1. Third root of 2, 2. Third root of negative 1, negative 1. Okay, and you can go ahead and sketch the graph of the function. So let's see. Eventually this graph wants to go down. There's a 0 at 2. There's a 0 at negative 1. And let's take a look. This graph really wants to be up at 8. When it starts, it wants to look like a positive cubic going through there. It looks something like this, but these are just pass on through zeros. So this graph looks something like that. Okay, probably some discussion on that, but we'll let you give the homework a try. And let's see, this is x to the 5th here. Doesn't show up very well on mine. So I want to set x to the 5th minus 4x cubed plus 8x squared minus 32 equals 0. I have to hope that this thing's going to factor by grouping. I can factor an x cubed out of this first two terms, and I get x squared minus 4, which means I need x squared minus 4. I can't always get it. But in this case, if I factor out an 8, I get it. Factor out this, and I'm left with x cubed plus 8. So x squared minus 4 times x cubed plus 8 equals 0. Either x squared equals 4 or x cubed equals negative 8. Let's see, that would be x equals plus or minus 2, x equals third root of negative 8, negative 2. So notice negative 2 is a double 0. We have a double 0 right here. We have a single 0 at positive 2. End model behavior, rise to the right, fall to the left. Other things we could do is we could say, well, it goes through negative 32, and as it's going through negative 2, it looks like a right side up parabola. But this is touch, so we come up, we touch, we get into here somewhere, and then once we come through here, we're going to go back up. Now, maybe it's wiggling around a little bit more, but on a big scale, the graph is going to look something like that. Understand, this is way down at 32. So, a lot of classroom discussion, a lot of things that we can talk about on that, but pretty quick page for you. And that wraps up 2.2, and boy, do we ever build off of 2.2 in the next section.